Welcome to the second part of this tutorial on Async Await and Azure. If you got here and you missed the Azure part, then you can go back to that and watch that, or you can just carry on from here and you'll learn about how to use Async Await with a little bit of Azure inside of Unity. Right, now let's get into the Unity aspects of this. So the thing to note here is that we're using the start method. And we're using a lot of synchronous calls to Azure. Now, Azure is a third-party service. It's not to be trusted. We should adhere to the fallacies of the network, i.e. that the network is always there and it's always present and it's always quick. That is a fallacy. We should be guarding against that. And if we're doing this kind of work where everything is synchronous, and the problem is that if Azure has been slow, the network's been slow, or whatever reason, there's some problem with your third-party service, we're now blocking Unity from working. So we will basically be like we're stuck in a tight loop, and we don't want that. So what we need to use is the asynchronous nature of .NET and the asynchronous APIs that Azure provides. And you may have seen that as I was typing some of this stuff in. So let's have a little look at what we've got here. So we're in our Azure test thing. Okay, that's sort of fine. Let's create a new script and start to try and move some of this out. So I'm going to create a new C# script in here, and I'm going to call it, what should I call it? I should call it Storage Manager. Okay, and do I want it as a minor behavior? I don't think so, not yet, if at all. So let's just tidy that up and come back to Azure test. Now I want to do all of this kind of stuff. Let's see if we can just kind of break it out a little bit. So let's have a little bit of refactoring. So we can call this connector container. And we'll have this as get container contents. Okay, so we got these, and then we can just, and the print's not going to work, but we can move these out into here. Tidy up the using statements. Switch out the prints because they're only on money behavior. Kind of a bit logically order these. Okay, so back to here. We can use our make that static as well for now. So we've got Storage Manager. Okay, so as with refactoring, we should just make sure we haven't immediately broken anything. To be absolutely clear, this isn't refactoring because I haven't got tests. This is just changing. Okay, but I'll call it refactoring because like everyone calls it refactoring incorrectly. Let's press run in here. So aircraft, Tempest, and then the details about the aircraft. So that's still working. I haven't broken anything just yet. Right, but we're still all synchronous. So let's make this not synchronous. So we do that with the async await pattern. So we're going to bring back, still going to bring back a blob container, but we use the async pattern. So the task now wraps the return result. And I'm going to rename this to async. Now it's gone green now because it knows that I need to do something sort of akin to a yield in Unity terms. But I won't actually have to do that. So I believe actually container client new. This isn't actually async, because this just creates the container. It doesn't actually do anything as yet. So to be fair, I don't think I need this to be async. Well, that's the easiest bit of refactoring. This, however, I definitely do. So async. And what am I going to get back? There's no actual results, so I don't need any results from that. So I just need to make this a task. Rename it async. It's going to get the container passed in. So now get blobs. Now this is definitely going to be async. So when we make that async, oh, yeah, okay. So when we make that async, we're going to return the task. So it's still, this code looks still pretty similar. The only difference is when we're enumerating over this container, as you can see, it's gone red. This has now got this async enumerable in it. So because it's async, it means we have to do an await on it. And what this basically means is, whereas before Unity was going through this step by step on its main thread, with the async await, it's going to move this call off its main thread. And then for every item in here, it's basically going to do like a kind of yield null would do in Unity. So we do the await, which is going to mean that we're effectively yielding on each one of these items in here. But apart from that, you know, it's a pretty minor change. We just need to make sure we use the async, and we need to do the await on here. And that's not the only synchronous call we're making here. So I think probably let's get downloads definitely going to be, yeah. So we're going to get a download response from that. Again, this is going to create a task, but in this case, we can directly wait on the download async here. So we can just do a wait. So again, that's changed from task back to the actual item that we're expecting. So the rest of the code can carry on working as normal. So in theory, this should just work. Now, the problem is with async is you have to kind of chain everything together. So if we go back to our test, so our mono behavior, you'll see that this has now got a squiggly green line on. Let's have a look what that says. Because this call is not awaited, the execution continues before it's completed. So that's kind of okay for us here. So we'll probably get away with that. So if we run now, okay, so it still works. Didn't really cause any problems. But let me show you what's actually happening. So if we do a print statement in here, so we say we have all the data we need. And then in here we say print getting the data. And then we ask for the data. So container name, getting the data. So we are starting to get the data. We have all the data we need. So as far as the kind of Unity aspect is concerned, we've asked for data and now we have all the data available to us. But then you can see that later on we say, oh, okay, well now we've got the name of it and the speed of it. So we're out of order. So if we were expecting to do something with this data, then it would basically be like having nulls and the data wouldn't be there. And that's not very helpful at all. So there's a couple ways of dealing with that. Now the first way is probably the simplest way, and this is the proper async await way, and Unity does support this, is you can come in here and say that the start supports async. Async task or async start? I think it's just async start. No, it's async task. And then you can just call await on here. So with await on here, what we're saying now is, okay, Unity, the start method that we're normally used to being asynchronous, I want you to make it part of the async framework. And as soon as you do that, any call that you make in here can now use the await. So what's going to happen is Unity is going to come in here, it's going to fire this method. We're going to do our storage container connect. We're going to say getting the data. And then the async framework is going to call this, and it's going to pause this start method. And when this returns from its asynchronous calls, we're going to then continue and then eventually finish. So our order should be as we'd expect it to be. So let's see how that works. So we get our container, getting the data. Now we get the Tempest. We've got the class. And now we say, oh, we finished. We've got all the data. So it's really pretty much as easy as that. We've now managed to take our code into an asynchronous world where we're not blocking Unity. And because Unity does actually understand async behavior, then it's really just as simple as doing this. So are there any problems with this? Well, yes, because the trouble is you're quite likely to have written a lot of code already that isn't async. So we're kind of back to this point where we've got our start method and we can't use await. Now, it may not be as easy to just simply put async on the start, because it does mean that the ordering of things behaves slightly differently, and that might cause your existing code not to work. So is there a way of having your existing code and being able to add on async await? So yes, there is. So what we have to do here is we can do things slightly differently. So what we need to do is come into the task, which is kind of where the async framework lives, and we can do start a new task. And this is just going to be an action. So we can put in the action that we want. Okay. And that's going to take whatever's inside of here off the main thread and run it. Now, you can see that this is going red because it's still waiting for the async. So this method here is going to be synchronous by default again. So we have to sort of tell it that this is going to be async. And that's pretty much all we have to do again. But again, bear in mind the order of things that are happening here, and we'll see what happens. So we run again. So aircraft, getting the data, we have all the data we need. So it's gone out of order again. So whilst it's async, and we managed to have the power of the async again, we're basically where we were before in a kind of fire and forget out of order problem. There are some ways to do this. So the start new is going to give us a new task. And what the task framework does is it has a continue with. So what we could do is we could do something like this, where we create another new action, and our action is going to be do the print statement. So some reason here I've messed this up. So it's saying that the delegate action here and doesn't take 0. So what actually happens is when the task starts running and it comes back, it's going to pass the result, i.e. the task, into the continue with. So we just need to pass that task in. And we should be doing things like saying if task is completed, or whether it's got an exception, all that kind of stuff. But, you know, that's what you should be doing. That's Azure World. Well, actually it's Async World, but we'll just leave it at that for make it nice and concise. So now we've got aircraft, getting data. We have all the data we need, name and tempest. So that still looks like that's kind of out of order. So that's not really helping us much. So what's occurring here is that the task of starting is happening and finishing, but that's not waiting for this. So that's probably not really much help. I don't think run is going to help us here. Let's have a little look, see if that makes any difference. So that's a bit better. So we've changed from using the factory. So the factory is going to kind of spin off that task in a kind of pool and look after itself. Whereas task run is going to create an individual task and run it, which to be honest, is fine. And now because that run, when that completes, the continue with is called, and then we're getting the data we need. So that's good. We have all the data we need. And the order is fine, so that's all good. Okay, but it's sort of a little bit tricky to continue with, to keep on doing that. It might not like it's quite an ugly kind of a syntax. So we can just go back and use something a bit more familiar. So on here we could have a static event action on data ready, and we could just say, well, all right, so we've done all our for eaches, we come out of here, let's just do on data ready invoke, and we come back to our Azure test, and we could then say, okay, we're going to connect, let's do an on enable why isn't that showing? On data ready we have all the data we need. That's just running that task. So this is a sort of using our basic kind of eventing model here. And hopefully that will give us the same sort of result. So getting the data, we've got the file, we have all the data we need. So I guess it's a case of style, your own personal preferences. I don't like having too many continue-withs. I mean, I would definitely prefer to make this async, because the code is just, as we see, it's far less, it's far easier to read. This is a little bit more, well, I've called this, and then you have to be aware that you're waiting for an event. So it's a little bit harder to follow. Again, this is why Async Await is powerful, because if you use the proper Async Await pattern, it's just far easier to maintain and read and understand and diagnose. It's just much better. However, as I say, it's quite often that you're trying to add async to an existing code, and in that case, you need to be using these kind of patterns like the task run. Okay, so is that it? Is that all we need to worry about? Well, not quite. So we've got our data, and can we just use it? So what I want to do now is, we've got an aircraft, and I'm going to add game object. So aircraft game object equals new game object, and we're going to give it the name from the aircraft. Actually, what we can do is into the storage manager, let's create just a public list of aircraft. Call it aircraft. Seems reasonable. Let's just new that up to begin with. Let's call it aircraft catalog, so it's not to be confused. Okay, so declare, yeah, okay. Because we're a static class, I've got to make it static. Okay, so the aircraft catalog we're going to add to here. Add aircraft. There's kind of slightly multi-threading issues that I should be worried about here, but for the sake of this test, we know we're only going to call this once. It's really poor design. Don't do what I do. But just for the sake of the argument, we're just going to add the aircraft to the catalog. So we're going to call the event on the data ready, and then we know that we've got our data. It's going to be populated. Right, so back to our test. So we know we're going to have at least one. Again, should be testing for this, but just for the sake of brevity, equals, so our storage manager is going to have a catalog of aircraft, and we're just going to pop the first one off. And I'm going to be convinced we're always going to have at least one. Yeah, poor code, right? But again, let's just go for it. So the aircraft.name, and then actually I'm going to put the speed. Let's put the whole thing on the two-string thing. So the name of it is going to be the speed, and the name of the thing is going to be included. So we've got our new game object, and I'm going to reparent that. Transform, actually set parent, transform, set parent to be this game object's transform, right? So when we run, what we expect to see is where we've got demo here, I should have a game object under here called aircraft, right? That's what you'd expect to see. Now, that hasn't worked. Seems a bit odd. Why hasn't that worked? Let's come back to our code. I've saved everything. Seems like we have all the data we need. Let's just make sure that we got an aircraft. Have we got an aircraft? First aircraft is okay. So we'll just grab that, and we know the toString is going to give us the details. Really? Oh, okay, because it's calling toString anyway, that's fine. So let's run that. First aircraft name is there, so why isn't it creating that? That's sort of mysterious, right? Should all be there. So if I just did it just doesn't seem, you know, it's kind of mysterious. Is it something to do with that, you think? Well, no, let's just create a new game object, set the parent. No empty game object. This is kind of ruddy mysterious. So let's come in here, let's go in the start, let's just do that, put it in the start. Perhaps my Unity is not up to scratch. Yeah, look, there's an empty game object. So my Unity seems to be okay. The data seems to be okay. So why, when I put this code here, same code, I just moved it into the on data ready. Not working. Bizarre. So the problem is, and this is where, when I said the Unity understands async await, the problem is it's not always very helpful about when it goes wrong. So what's happened? Let's take a look at this code. So we've called task run, which has taken the code away from Unity's main thread, which is what we want. So we're in a different thread somewhere else, and we're doing this work, and that has called an event. Now when it calls that event, so let's follow this through. When it calls this event here, we're still in this other thread. We're not back on the Unity's main thread. So although in here we're getting this event isn't running in Unity's main thread. This is still running in this other thread. So whilst we can access the data and do things with it, what we can't do is we can't access Unity's UI, because that's running on Unity's own thread. So what we have to do is we have to dispatch, and that's what the term's called, dispatch onto the UI thread. Now, there isn't anything out of the box to do this. So I found, let me just go and switch over to another project which I've got running, and shall find the helper and bring it in. Right, so let me just find this file, Unity main thread dispatcher. I'm going to copy that. And we're going to come into scripts, create a new folder in here called helpers, and paste this in. And I'll show you where I got this from. So we just let Unity catch up with a new folder structure. So this is written by this Pim-de-Wit. I'm sure I've butchered his name there, or her name, but you can get it from here. So this is the Unity main thread dispatcher. And what this basically means is we can come back into our test and we can say, okay, I've got a piece of code and I want to make sure that this runs on Unity's main thread. So now we can do Unity main thread dispatcher. I think it's a singleton, so you can do instance enqueue. It's actually got enqueue async, interestingly enough. And then we can put an action on there. So our action is we're going to do some work here. So all we're saying here is, okay, we've come in from our data ready, which we assume is on this other thread. Do a little bit of work here to get a catalog item. And then we can say, well, all right, I know I need to do this piece of work, but I want to ensure that it's going to run on Unity's main thread. So we can use this thing called a dispatcher that is going to queue this work. And basically all it's doing is it's going to be essentially a mono behavior that when it loops around, it looks to see if there are any items in its queue of work to do, and then it's going to run them. And because it's on its own separate thread or its own separate behavior, it's going to be guaranteed to be running on that UI thread. Oh, bit of a mouthful. And what we have to do is put this code into the scene. So put the helper, let's create a new empty object. What we call it? Main thread dispatcher. Just make sure that's up there. Okay, and that makes a singleton work for it. That's the way it does its singletons. So now when we run, we've got a new game object. Hooray! Why didn't it give it the proper name? That's odd. I was expecting the name to be correct. Just move that into there. It should be correctly scoped. Oh, okay. Not sure what happened there. Right, so we've got name, tempest, speed. So we've got our data and we're now able to use it within Unity. So I think that pretty much wraps up this kind of slightly tortuous async await demo with using Azure. But I mean, Azure wasn't really the important part here. This was really to say that when you've got something like Azure, which is on an untrusted service, you've got to really think about the fact that it's not going to be available. It's not going to give you data back in time. And if you're using something that isn't going to give you data back in time, then you have to start thinking about asynchronous and non-blocking calls. And really in the .NET world, synchronous means you're going to use the async await framework. And if you're going to use the async await framework with Unity, then the two real takeaways are, if you can, just use async natively, because that's going to be a lot easier. If you can't, then you have to end up using something like this task run mechanism. And either way, you're going to have to consider using a dispatcher. Whenever you've got any kind of results back from the async await, then, or you're inside an async await, then chances are you might not be on that main thread anymore. And as we saw, if you're not on the main thread and you do some work, Unity is not very good at helping you see that you've got a problem. So if you start seeing kind of a bit obscure behavior or things you expect to happen aren't happening, then chances are that what you've got is you're not running on the main thread. So I hope that's been helpful, and I shall be doing some more of these tutorials about using some of the more interesting features from services using Async Await, and I hope that they will be coming soon.